We're back. Please like and subscribe. And today we're going to be talking about exciting things with our expert, Daniel DeVeau. So, Daniel, please introduce yourself and why are you a good candidate to tell us about performance?
Sure thing. Hey everyone, making my live stream debut here. Happy to be with you. So yeah, I've been working on performance, Appian performance for 5 years now. Manage a performance team, and I've worked mostly, as April said, under the hood on the Appian components, the back end on Appian Cloud. So hopefully I can answer your questions about the Appian architecture or anything you guys are that's on your mind about performance. So let's get some questions and let's talk about performance.
Sounds great. Yeah, I'll be watching the chat. Hopefully our audio is good throughout the rest, but please ask your questions. And Sam said this in his intro, which I think we were muted for, that and I agree the same is we're both not experts here, so we're also learning here with you today about performance. So let's get started with how does Appian work? I mean, I think we take for granted sometimes that all we have to do is open up a web browser and log into our Appian environment. But what are all the things happening behind the hood?
Sure, yeah, there's a lot going on in an Appian install that luckily you don't need to know about if you're just developing on the browser, but a lot of different components that go into Appian being fast and reliable for you. So have our diagram here. I just want to highlight, at the top we've got the user browser, your web traffic coming in, going through a web layer, and then the main entry point here is in the middle, the application server. So that application server is what's going to be consuming that web traffic, consuming your requests, parsing it and dealing with the requests, sending them out to the other components as needed. The other boxes of components we see, primary database, data server, search server, all of those hold different data and are optimized to process and work with that data. If you guys have specific questions about those components, throw them in the chat. But I think today I want to focus mostly on that bottom left box and talk about the Appian Engines. You may or may not have heard of them, but I'm going to do a little intro here, which I think will hopefully provide some context to developers for the rest of this talk. So looking at this Appian Engines box here. So engines are K databases. So K is this in-memory database language that is basically made for really rapid processing of certain set of data. So the way that Appian works with these engines under the hood is we have different databases, different processes for each type of Appian data. So if you look at those blue boxes there, starting on the left, we have these process engines, and these engines are all about making your Appian processes run reliably and quickly. Arguably the most important one is that process execution engine, and that does exactly as the name suggests. It executes processes. And you see these ones are plural. The process execution, there are multiple of them just because that's so important. That's something that you can scale up to run more processes on your environment. To the right there, process analytics engines, those do reporting on processes. So your process reports, your task reports, we have dedicated engines just for reading that process data to make sure that that's always fast. So thinking about performance in your development considerations, if you have a super process heavy workflow, you're going to be thinking about that impact on the execution engines. And if you're just doing reports, for example, you have home pages that all the users are hitting that have large reports on past processes, that's going to be analytics engine working. Going to go through some of the other ones quickly too. The design engine, that's holding that actual process model data, not executing it. Content engine there, that's holding your Appian objects, content objects. That one is involved in most everything you're doing in Appian because you're always working, displaying objects, work with objects. To the right there, personalization, that's handling your users and your groups. Again, another engine that's all over the place. If you think about all the security that Appian offers, you're always checking, group membership, multiple times on pages, and that's personalization engine doing some of that checking. And I think we can skip some of the other ones. They're less critical, but if you guys have questions about them, please ask. So then just to complete this little box, you see some other components there, Service Manager, Kafka, Zookeeper. Those are all just about facilitating these transactions, making sure that, when what you're running on Appian is actually getting through to the right engines and it's all staying, reliable and saved and just all part of that ecosystem of keeping Appian running fast.
Sounds good, Danny. We have one question, and maybe this is not a good place to ask it, but is the new translation object structure efficient enough and performant enough for big applications with a lot of logic, and how do they behave with static dropdown? So I wonder if you know, like, where are these new translation objects, what engine handles these, and kind of, it seems like since it's the same as most other Appian objects, it should kind of relatively work in a similar manner, right?
Yeah, I'm not aware of any unique, like, from the architecture side of anything in the back end. I'm not familiar with actually the implementation of that feature, so I actually might not be the best one to answer that one.
All right, we'll look that one up and throw it in the comments later. But it is a new Appian object, so I'm sure it probably uses the same engines that other objects use, right?
Right. So things that are like the browser there, a lot of that execution is going to be in that application server, going to be in Java. So in that top component, so the main performance consideration there that is your CPU. The size of the box, things like that. That's the main consideration for just general, I would say, like sale features.
Okay.
Uh, yeah.
We do have another question. So this is great. Already so much chat engagement today.
Nice.
So Stefan asked, how scalable is the engine that handles groups, memberships, permission security? So I guess that is the personalization engine. So are 50,000 plus groups a problem for that?
Mm, right. Yes. So as I mentioned with the process execution and analytics engine, those ones have multiple shards, just because those are so much more commonly the most heaviest use. So those you can scale up and down the number of pairs, starting with a default of you have 3 execution, and it can go up to 16. And the groups engine, there's just the one. So the only way you can scale it is by having HA distributed environments, basically like more copies of it. So those are more replica engines that are all replicating the group's information. So you can perform more reads on the group information by having more servers that host the engines. I hope that makes sense. But you can't make multiple copies of them that are all like writing and changing groups data. Um, so as for having a huge number of groups, I would say that the engine can handle it in terms of like the storage of it. There aren't I'm not aware of a hard cap or anything like that, but when you're dealing with a huge number of any object, as I think we might get into later, like design objects or record types, but or groups, once you have a huge number, when you're trying to uh, interact with that and iterate through it, as search things like that, that's where you can start to see the performance impact. Especially, there are plugins. I think people functions is a common plugin where you might do some more advanced group search and manipulation. If you think about if you're triggering an action that has to be done on tens of thousands of groups, that's just going to be slower. And uh, one of the problems with that kind of activity is the groups engine, as I mentioned, it's so important because you're checking group membership and security all over the place. So if you're doing something like a big group manipulation, like moving users around, deletion, like something that's going to interact with your tens of thousands of groups, that might interfere with just individual user trying to do something a lot simpler on the page. So that's why if you're you got to really be careful with some like mass group modification events, and make sure that you're doing something like that maybe uh, off hours, at night. Or if you have a use case where ahead of time early on that you're going to need um, those high amounts of groups, you definitely think about what are you doing most. Are you just checking if a user's in a group, or are you doing some more expensive operations on the group? And um, depending on the use case, it might make more sense to have that group structure actually be in an RDBMS instead of being in the Appian groups. Yeah, it all depends on your use case. And overall, general answer for all such questions about uh, abnormal use cases or huge amounts of objects, load test. That's like, make sure don't leave it up to chance, like this works with 1,000 groups. fingers crossed it will work with 100,000 once I go live. Don't, actually try your best to put some realistic scenarios in and test for sure.
So, if I could just recap that,
Hmm.
basically, when we're just checking if a user's in a group, that's not too bad, but you don't wanna, like, on a simple page a user's gonna be going to, like, within local variables or, like, when they're doing actions, try to, on that page, manipulate groups or do, like, writes or edits to groups, like, from there, right?
Yeah, so there's only one of the what we call a primary engine, the one that can actually do the writes.
Yeah,
So which is a common, that's a common design when you have multiple copies of some kind of database. One's doing the writes and the others are doing reads. So yeah, if you're doing manipulation, that's taking up that write, that primary copy. So
yeah.
you can only do one of those at a time. So it could be an expensive operation. But yeah, anytime you're doing that kind of, like you said, iteration in local variables in sale, um, you want to be just considering the impact of that.
And so when we are doing things with either something it's just one engine or multiple engines, how do we decide like in what order things happen? Is that just like a first in, first out kind of thing?
Yeah, for the most part, that's just that's part of what the those processes you see in the red there, the service manager, Kafka Zookeeper, those are part of ordering the transactions and keeping the order stable and proper. I mean, maybe one example I can think of that's interesting to answer that is about activity chaining, which you guys developed in process models you might be familiar with. That is a way that you kind of tying multiple transactions together to kind of skip the line that would otherwise be um, a more of a round robin with process work. When you're chaining, you're putting multiple nodes together into one transaction, which is important at some times, but also again something if you're overdoing it might be problematic.
Be considerate. Don't hog everything up. Also, now that I've heard you explain this, I just made the connection of why Zookeeper is probably a good name for something because this does sound like a lot of chaos that you need to keep in order. Um,
Yeah, and for the record, the Kafka and Zookeeper, uh, those are I think open source technologies. Those are not like we didn't create those names.
Right. Yeah. Cool. All right. Yeah. And as Stefan said, that question was mostly about the impact on the security and membership checks. So it seems like,
Mm.
yeah, the checks should be okay with a lot of
Yeah,
groups.
the check is a super cheap operation. Yeah.
Yeah. Cool. Okay. So, yeah, chat, keep them coming. But for now, let's keep going with this. Okay. So I kind of understand Appian has these engines that decide what to do. Now, okay, what have you seen as like some of the things that could impact performance the most and like considerations we should make more specifically than just hey, if you use a lot of something, it's gonna be slower.
Yeah. Sure. Yeah, I mean, I think one category we could tackle this from is memory and memory usage. As I mentioned briefly, these engines are all in-memory databases, and that's what allows them to be so fast. So they're holding the relevant information in memory, which obviously consumes resources, but that allows it to be a lot quicker. So memory usage is something that you always want to be careful of not overdoing. It just in software in general. So I think maybe there's a few things we could talk about that things to think about and potential places where memory could be overused.
Right.
Uh, one would be queries for sure. If we want to talk about queries.
Cool. Yeah, just before we get into this though, I hear you say memory and then we talk about
Hmm.
databases and storage and to me that could sometimes feel the same. So what do you mean when you say memory versus a database versus, whatever, things happening in memory? Help
For
me
sure, yeah,
explain to me like I'm 5.
yeah, for sure. Like, uh, yeah, so memory and disk are both storage. Disk is your larger, uh, cheaper but slower storage. You're often going to have hundreds of gigabytes of that on your computer or phone, and so like I said, you could have a lot of it, but it's pretty slow to access. So you don't want to use it for something that like a user's waiting for on their computer. You want to use memory. So memory, RAM, random access memory. That is the memory that's used by running processes. So there's less of it. You're going to have 4, 8 16 gigs on your phone or computer, but it's faster for this exact reason, because it's able to serve data that is on page that running processes need. So when we're talking about memory, we're talking about the RAM, and it's used by everything. So anytime that you're running your sale expression, uh, more or less everything you see is being loaded into memory in some way. I don't know if we could use an analogy. I don't know if you want to throw that in
Yeah,
there.
yeah. You mentioned an analogy to me when we were talking earlier, and I think it was a really good one. So I'd
No,
love for
it's
you to share with the group.
Yeah, sure. I always liked the thinking of books and where you're keeping your books in your house, right? So you've got the library, which is where you can hold, infinite books, any book really. But of course, you have to go drive there. So that's your disk, is large amount but slow to access. Then you've got maybe your bookshelf in your room. So you've got a good number of books, not as many as the library, but you still got to go stand up and grab it. So you're probably not going to be um, going, like, the book that you're currently reading, you're not going to be going and putting it in there and out of there um, every night. So I think that maybe the bookshelf is more like your RAM, so closer to you, more of it, but less than the library. And then something like your bedside table, where you've got just the book you're currently reading, that's where we can think of as cache, which is taking the same idea further. That's even much smaller. Talking about often megabytes or 1 megabyte of a cache. That's just the memory, the data that you're using right now. And there are all kinds of caches in Appian, to hold different kinds of immediately relevant data. And also your browser has multiple caches that are, it's saving content, like what we can see here. On Sam's page, we're probably saving like the Appian logo and the header and things like that are on all of our pages are going to be in the cache, so that the browser can just load them without you having to um,
Wait for
go
it.
go to Appian and back every time. So
Yeah.
that's why you might notice that, like, the first time you load an Appian page in the day might be a couple seconds slower, but then navigating later is faster. That's probably because a lot of that content is now cached and not being sent back and forth.
Yeah. Um, okay, we got another question about node completion and code execution, but maybe when we get to process models, we can talk about that.
Okay.
And so we'll get back to that one. And for now, let's kind of get into this query example. So Sam, you have this open. Maybe you could talk us through what this is. I mean, I do see right away the 13 and a half seconds wait time, which for me, I don't have time for that, you know?
Yeah.
No.
When I tested it earlier, I was sitting here waiting and I was like, is it ever going to finish? Yeah, nobody wants to wait 13 seconds just to get their data. And I think, Daniel, your analogy was perfect. That definitely cleared things up for me. I love the library analogy. But
Good.
yeah, you can see here what this rule is supposed to do is it's supposed to get all of our orders. So this is for an order fulfillment process. It's supposed to get all of our orders and the related messages that correspond to each of those. And so you can see for each of our orders, we're actually querying into our message threads to get all the messages related to that specific order. And we have a large batch size getting involved. And you can see Appian's even kind of yelling at me. It's like, hey, this output is too large. We've truncated it. And so that to me is immediately being like, okay, maybe something's not right. But then you can also see here, like I said, nobody wants to wait over 13 seconds to get their data. So we definitely have some problems that are being faced here with this query.
And then I also see there's a view performance link next to the time. So what happens when we click that?
Yeah, this is going to give us a really good insight into what that time number there means and what is taking up the most time. And so you can see here of that 13 seconds, or I guess in this case, 9.541, almost all of it is in that for each. So you can see our initial query took not that long, 90 milliseconds, but then everything else after that is taking about 10 seconds. And so you can kind of go in and navigate, okay, what's going on? I can see a bunch of my query information is taking forever, and it's being called over 300 times in each case. And so this gives me a really good idea of what I can improve. And it's all right here. And I know Daniel will get into a little bit, but we're querying within a for each, which I know is a big no-no. But and that is what is taking so long. So we were able to quickly investigate and figure out what was taking this expression rule so long.
Yeah, and when I see this and now thinking about your book analogy, so I'm kind of imagining, okay, our order submission table in the database, that's the library. And we're saying in our local orders, okay, let me bring all these books back to my house, 1,000 books. Okay. And then I'm saying for each of the 1,000 books, like when you're doing a for each, the FV Bang item is kind of like the book on your nightstand, right?
Mhm.
So for each of these 1,000 books, I am going to put it on my nightstand, but then go back to the library and get another thing about that book versus just thinking about those filters and fields like when I first start, right? So you can just imagine that could get out of hand really, really quickly. So
Yeah.
any other notes on the kind of looping aspect of it, or should we just jump in and see the after Sam's cleaned it up a bit?
I mean, I think the batch size is an interesting thing. Is that something we wanted to? You had another example for Sam, or can we tackle that now?
Yeah, that's right. So I kind of have this after,
Mhm.
which is same expression rule. We want the same outcome, but you can see I made a lot of changes. First off, this one's only taking 86 milliseconds. That's phenomenal. I mean, that makes me, I don't even have to think about it. I don't have to sit here twiddling my thumbs while it waits to happen. But some of the things that you can see that we did to make that performance jump so drastically, I'm not querying for all the fields in that record. I'm only pulling the fields that I really will need for what this use case for this query is involving. I'm also taking out my for each, and instead I'm querying all of the messages. And then you can see later on, I will just index into that giant query and pull out the information that I need. So April, like what you said earlier, for each book, instead of going back to the library to get whatever information I need for that specific book, I'm just going to bring everything with me at once, and then I'll pull out what I need when I need it. And so that was very helpful in reducing the time. And then the last thing, you can see I implemented some paging. So for my previous example, there's never really going to be a case where I need to show all 300 items at once. And so I was able to implement some paging where I only want to show based on my batch size, which I put as 10. Let's just show 10 at a time. And then this could be dynamic based on whatever paging we involve. And you can see it drastically changes our performance time, which is perfect for our use case.
Yeah. And we live in a technological world. We're used to interacting with things like this, right? When I'm on my Amazon orders page, I mostly just care about like, oh, when is my most recent order coming? I don't quite care about things that I ordered 2 years ago unless I'm searching for them. So when I first load up the order page, it shows me a smaller subset, but I have the option to request more, but I know the further back I go, the longer I'm going to have to wait to get all of that back, right? So a lot of these things if you just try to imagine any other technology, like they feel kind of intuitive just with how we're used to interacting with the world. And also how we're used to interacting with the world is I don't want to wait. So make people's life better.
I think Google search is another example too.
Yeah.
Like how often are you going to the second page? Part of that's because Google's so good at it, but I think paging, we can't overstate the importance of paging for sure. It might be obvious to some of you, like don't batch size -1, like batch what you need. But I promise this is not obvious to everyone. This is an extremely common cause of performance issues. So first of all, like think about how many items you need to return and try to keep that to the minimum you need to. And if you're displaying, say, on a grid or displaying something to users, they really are not going to be consuming more than 25, something like that. And that can be really important.
Yeah. And one other thing. So one reason you might like, oh, I need -1 because I need to know how many rows there are. Well, actually, the data subset will tell you what the total count is, right? So you can see, in line 30, Sam is doing dot data to actually get just the data out of the data subset, but the data subset gives you a lot of information that may be helpful for you to use, like how many more pages there are, like, what the total count is and all of that sort of stuff. So yeah, there's really never a reason you need to use -1. Chat, if you want to try to make your case, I'm happy to hear it, but I don't believe you.
Yeah, actually, fetch total count is an interesting thing you bring up. Like when you're
Yeah.
doing query entity and you can choose to return the count or not.
Yeah.
Under the hood, that's another query because you're
Yeah.
running the query for the data, and then you're asking the database, well, how many rows actually are aligned with this? And that's a separate query. So that's another thing where if you don't actually need that count, sometimes you absolutely need it. Like I think it's built into grids, things like that. But if you don't need it, have it disabled. Like
Yeah.
just, default to the minimal information required. And that will really help on your performance journey.
Yeah. Cool. All right. Anything else for queries, or should we maybe we can use the process model question as our transition into talking a little bit about process stuff. So the question, what is the difference between node completion time and code execution time? If a node takes 1 second, does it mean the code actually took 1 second? So what does that mean?
Yeah. So I think this person is talking about what they see on the when they're looking at the actual node completion time here in the process modeler. Maybe Sammy can pull that one up in the details. Yeah. So you're seeing, for each node how long it's taking, and maybe you've noticed that it's longer than you expect, or sometimes you might run a rule in Sail and you see that it's faster than you see it in the process modeler. So what they're getting at is, there is a difference between just how long the code actually takes and how long the node takes. And the reason for that goes back to what we talked about with the architecture. Remember, we had the application server, which I did mention was doing some Java, and then there are the engines which are running the process. So in order to facilitate that, basically some work's being done in the process engine and some is being done in Java. So that's work going back and forth. For example, if you're doing something like an integration call, that's going to be that application server. But things like these XOR nodes are going to be in the engine. So whenever the work needs to go to the application server, that's being put on what we call a work queue. So the work's being basically queued up to then be pulled and picked up. And in order to facilitate that, that work is being pulled on an interval. It's not being, infinitely immediately pulled. And I think the interval might be 500 milliseconds. So what that means is that you might see the completion time being 500 milliseconds or a second when the actual work was a lot less than that. And that's due to that polling process. And again, one way I mentioned before, but one way you could interact with that process is with activity chaining. So what that's going to do is attempt to, it's going to put multiple nodes into one transaction to go onto the queue. So you can effectively skip the line, which is important when you need to. But then, you're causing the engine to work more on one process and less on others. So more of like a depth first execution than breadth. So I'll stop there. You guys want me to talk more about it?
Yeah, I think that's definitely really helpful, and it's kind of like, yeah, whenever we need to tell things to talk to each other, it's going to take a little bit longer because we need to tell things to talk to each other, right? It's and that's kind of like the beauty. We can do more when we're talking to each other, but we might need to it might be a little bit slower than when we're doing things ourselves to start, but then we can scale that. I don't know if that analogy makes any sense. I think your book one was probably better.
That makes sense to me, April. If it makes you feel better, that makes sense to me.
All right. So, what else can you tell us, Daniel, about processes, and what are the things to look out for when we're talking about building efficient, performant processes?
Sure. Yeah. I'd be going to keep with the memory theme, right? So your process, again, that execution engine is that in-memory database. So the processes that are running and that are completed are sitting in memory, which is great for when you need them, but not so great when you don't need them. So I think one tip is just to manage that archival and deletion settings. We do see some cases where a customer will turn off the cleanup and for a process that they're running a ton and they don't actually need. This feature is here so that you can keep the processes that you need, often for auditing purposes, and so that you don't keep the ones you don't need, right? So if you have a process that is going to be audited, okay, set it to whatever that audit needs it to be. But if you have something that's all back end, all automated system, you don't anticipate ever needing to look at it or audit it, be aggressive with those settings. So archiving the process will move it out of memory into that disk storage, right? So bringing it back to the library, so you can still grab it later if you need to, but it's not right there on that process instances tab for you to review. And then the deletion, getting rid of it for good. So just something to keep in mind. You have a default on your site which you can configure with a property. But think about that for, especially if you're building a unique process that you might need to keep for a long time or not. Think about being aggressive with those settings.
Um, that makes a lot of sense. And it seems like it's all coming back to memory. And so along with the memory thing, we also have process variables, right? So what's the impact of kind of trying to hold too much data in those process variables?
Yeah, so for the most part, the process variables could it'll be okay. You pass around what you need to, but I think we can see this anti-pattern sometimes when you save too much. Often, the results of a query returning all values of a CDT, something like that, and saving it to a process variable. Again, Appian can handle it. It will be what it will cause though is that execution engine to be large. So maybe that's okay if you have a really big site that has a ton of memory, but if you're holding something like a massive string, gigabyte, something that's way too big for someone to ever really look at, you could hit problems when you try to open this page and actually look at it, right? Because it's much more data than this entire page shows. So overall, you want to avoid saving really large like text data, especially directly into a process variable.
Yeah, that makes a lot of sense, right? Just take what you need, don't take more than what you need. Keep things going here. Yeah, if any more questions, keep them coming. We love putting Daniel on the spot over here. So, all right, let's talk about some other parts of Appian. So, plugins. I know that you're familiar with plugins. So, they're ubiquitous, right? Like no one is building apps without plugins. But what should we be considering when we are using plugins?
Sure, a lot of things. I mean, plugins are obviously super important way to enable new things in Appian that you can't otherwise, but also can be risky just because at the end of the day, when you're executing a plugin, you're going from that Appian core code into the plugin code. And we have a lot of great developers developing great plugins, but I think that often you're not going to be reviewing the code yourself before deploying a plugin. You're probably just going to trust it, and often that's okay. Oftentimes it's okay, and sometimes that's not. So plugins can definitely be a source of memory concerns and issues just executing. I mean, let me think of some categories. Like a main category of plugins is your document generation. Here's what I see right here. Like, well, content tools is kind of manipulating and accessing your content, but I think of some other big ones like your Excel tools, dynamic document generator, PDF tools. One big category of plugins is doing this kind of thing, creating documents, manipulating them, combining them. And I think what's important to note about those kinds of document creation processes is they're going to use a lot more memory in flight while they're doing that document creation than you might expect. And that's because what's really happening is, Appian's passing the torch over to this plugin code, which is often going to be passing it to some third-party library that the plugin's using to do, that Excel or that PDF work. And often what that means is, it's converting, don't need to get too technical here, but it's converting your doc into a bunch of Java objects, right? So if you have if you have like a 50 megabyte Excel file, in order to manipulate that, it might need to save every single cell as some kind of Java cell object, which is going to be a lot larger than the real Excel file, right? Because the Excel file is optimized for what it is, but moving that all into Java, not optimized for that. So it's going to use a lot more memory, oftentimes multiples, than you would expect. So I would say maybe number one consideration for especially those type of plugins is to think about your inputs and, if possible, restrict the size of those inputs. If the user's passing in a file upload, something like that, be realistic about what is this use case? What exactly are these documents being passed in? If I'm expecting a one sheet Excel file, maybe I'm not going to accept 50 megabytes. And again, you really got to test that to be sure because it varies by plugin. But I would say that's number one is being careful with those document generation plugins.
And then another thing we're seeing here, this is kind of new. I don't know if people have experienced this yet, but this outdated plugin banner up on top. So This is another thing that you should go on and check. We now alert you when, hey, there's a new version of this plugin available. And over on the app market, you can also, on individual listings, kind of subscribe for updates. So you'll get an email when there's a new one, but you can always go into the admin console and check here as well. And so, why should I update my plugins, Daniel?
Sure, yeah. I mean, yeah, this is very important. I mean, the plugins these days, all code libraries, all software is updating often, really often, just because that's where we are in the world in software. So, uh, a lot of these plugins are going to have third-party libraries, and a lot of these updates are going to be third-party library updates for things like vulnerabilities, right? And so that's the number one main important reasons, right? Keeping them updated is keeping your environment safe for sure. Though also, that doesn't mean that all of the updates are riskless, right? You have to, especially if you're updating a critical plugin that's used on production workflow. Go ahead and check the release notes, see what you're actually changing. Like put it through the normal dev test workflow. Don't take it for granted that it's 100% going to work, because while the developers likely did test their code, they couldn't have possibly tested on like the entire Appian ecosystem, right? Everyone has different use cases, and often, like I said, they're not responsible for these libraries that are changing. So there are a lot of variables. So be careful with it, but also it is really important to keep them updated.
Yeah, it looks like I have some work to do here, April.
I know.
I got some plugins that need updated, so my hands are full.
There was one other thought I had with plugins. Let me see if it comes. So another thing that happens sometimes, and it's I'm struggling to remember off the top of my head right now, but sometimes Appian actually will build that functionality into the product, right? Or we'll make a plugin first because it's a lot easier for one person to build something than for it to go through our hundreds of people, engineering department and QA department and everything to get properly into the product. But when there is some plugin functionality that gets baked into the product, should we be switching those over?
Yeah, I mean, you definitely should. And Appian, we're always consuming ideas and deciding on the best ones and implementing them. Product use cases is one way that you have. Feel free to submit a support case, talk to us about ideas you have that you want to put in the product. And one such way is plugins. We might put them into the product. The last one I can think of was the execute stored procedure that everyone was using stored procedures for the database. We put that into the product. And yeah, overall, I mean, you're getting the support of Appian when you're using that out of the box, right? And the plugin, as opposed to the plugin, and you're going to be getting those security updates automatically when you restart your site, as opposed to relying on doing this manually. So for that reasons, it's definitely better. But again, sticking to that execute stored procedure as an example, I'm aware that there are some differences in the functionality, so that's another consideration.
Yeah. All right, there's one question about plugins, and also this has been flying by really fast, so please ask your questions because we're going to be wrapping up here shortly. But is there any way to identify memory consumption issues with plugins?
Interesting. So I think, the plugins are often going to be, I have to think about that. Well, there's two types of, I guess, problematic memory consumption, which would be the like in flight, like I was just talking about. The PDF is merging. For that second, it's going to consume a lot of heap memory, which is a specific type of Java memory we maybe don't need to get into, but it's going to be consuming that memory to create the document really quickly, and then it's going to clear that out. So that's not like a long-standing type of memory. And in order to track that is actually pretty tricky. Really, what you have to do is load test something like that document manipulation, sticking with that at scale. Think about how many of these are we going to do, Because if it works one at a time, it might not work if we're doing 50 at a time on production. So and there's really no substitute for actually testing that out. For Appian Cloud on my Appian, you do have the heap memory, and the garbage collection values available, and that is where you could see an impact of something like that, like a short memory spike. You would see that in the heap and garbage collection values. So you could like try that individually for if there's something that you worry might be intensive, like what I've described. You can check those values. Also, there are logs. The data metric system CSV log, that's one that would display those same kinds of values. So that's one way to do it. And then I guess for the longer term, like memory, something like we talked about, the large process variables, I guess that'd be another way that plugins could, plugins also just execute sale expressions and expression rules. So you can use the what we already talked about to see the performance and see the memory usage. Actually, on the monitoring tab, we didn't talk about that yet, but that's one place where you might like seeing the memory usage of a process might lead you towards something like a plugin saving too much memory, something like that. So.
Yeah. Oh, like it looks like this process that uses a plugin is much more of a culprit than this other one.
Yeah, I think that's less common than the first example I talked about, which is like a big spike of memory that could, put the site at risk. That maybe is more of what they were talking about.
Okay. So yeah, you mentioned monitoring view. Why don't we jump over, Sam, to the we just have the slides with some screenshots from the docs because they have a lot cleaner sample data there for us.
That's
so
right.
we can go just look over, and while we're just reviewing these resources, your last chance to get some questions in, we'll just wrap up covering this, and then I have an announcement at the end, so stick around. All right, so let's walk through. Sam, why don't you walk us through what each of these are?
Yeah, so this is going to be on the monitoring tab from Designer, and so I find this view very helpful. This is kind of like I kind of think of it as like a master command center. It's going to kind of tell you everything that's going on within your applications. And so you can see starting on the health dashboard, we're going to have just overall process activity and process model metrics and record response times, as well as sync status. So this kind of gives us a really good overview. And then you can see each of our tabs actually correlate to these items, so we can actually drill in further and learn more. So you can see process activity is covered here, process model metrics down here. And then it also gives you design guidance. So where are you maybe not using a local variable that you have called that's storing data, or ways to clean up your interfaces or processes to make them as clean and efficient as possible. So this is kind of your master dashboard kind of view. And then, as I mentioned, as you start to drill through, you have your process activities. So all the processes that are actually being ran within your environment. How are they going? Are they completing? Are they erroring out? What are those errors? When did they start and complete? And who ran them? So a really good insight into kind of how your processes are working from a high overview. And then, as mentioned, this is where kind of some of those metrics and reporting numbers come in. You've heard Daniel talk a lot about memory. You can see it's going to kind of give you some good insight on which processes are using more memory than others, which are being called more than others, and how are they completing. So this is a really good way to look and see, okay, I have this process that's taking a lot of memory. Maybe how can I clean it up, or how can I make it run faster, make it run better, so that I'm not storing as much memory.
Before you move on, I see AMU. I've heard of like CPU. What's AMU, Daniel?
Yeah, AMU is like it's an Appian abstraction of memory, RAM, same thing we talked about.
Yep.
As far as I'm aware, I think it's like roughly 1 kilobyte. I'm not 100% sure why it's abstracted, and we're not showing like just the straight up computing values, but I think we have some docs we can share on green, yellow, red, dangerous values for this. But it's just you're looking for huge numbers there for problematic processes.
Cool. Yeah, and all of these screenshots we pulled right from the docs, from the monitoring monitor view section of the docs that will walk you through all of these. It'll tell you what all of these little number flags mean, and it'll link you to other areas of the doc so you can dig a little bit deeper. There's too much to cover just in this time. All right.
That's right.
Sam, finish us up here.
Yeah, so obviously love the docs, but just keep going through here. This is just again a great way to just view your numbers and how your processes are performing. Similarly, you have the record response time. So just similar to how your processes are performing and what memory they're taking up. You also have how are my records performing in different areas that I'm using them, whether it's within a process or within an interface. What is the response time? You can see we have a 38.4 second response time, and it's giving me a red notification. So maybe we look into that one a little further and figure out how we can optimize it a little better. So again, another really good resource here to figure out how your data is being received. And then lastly, you have the record sync status. Actually, not lastly, there's one more. You have the record sync status. And this is telling you how your syncs are performing. So you can see we had a failed one, so we can investigate why did it fail? What was the issue? Running, completed. Just a really, really good resource to have from a high overview to make sure that you have all of your most up-to-date data. And then lastly, as I mentioned, portal monitoring. Obviously, we all have portals, and this is a great way to figure out how are they performing. So are they published? Are they not published? What errors are we seeing? What is the traffic coming in and out and the timing with that? And so, again, as I mentioned, this monitoring tab is just a great way to have a very high overview, kind of like I said, the command center for all of your objects within your applications and figuring out where you can start to optimize different items.
So portal monitoring, this is a new one. And, translation set's also pretty new. Portals has been out a little bit longer. Daniel, have you guys seen anything like in your performance squad when it comes to portals and maybe anything people should consider when they're building out their portals?
I've never worked on a portals performance issue. Maybe one that my global team has, but as far as I know, that hasn't been a performance risk so far.
So that sounds good. I mean, especially it's out on the open internet. People don't know it's Appian, right? So that's really good to hear.
Yeah, and another, maybe just throw a quick plug for my team, right? So if you're looking to troubleshoot some performance, follow all of these things that Sam's walked through. Look through our docs, go through these resources available to you. If you have exhausted your options, look through everything that you're aware of, and there's maybe something slow that you can't quite understand, reach out, Appian support case. We're here to help uncover those kinds of things.
And we also have a community as well, so you can
Yep.
post your questions there before reaching out to Daniel.
Yeah, post your questions, check if someone's already asked and answered. Exactly.
That's true. Yeah.
Most of the time, someone probably has.
Someone has probably had. That's true. We have a couple more notes. So thanks everyone who was active today in the chat. Jim said plugins can also be a tool for shifting load away from PX engines, for example. And then he has another tip, which is changing PM cleanup settings takes effect immediately upon publish, including existing process instances. So that's a good thing to note.
Yeah, that's an interesting note. And do we have a second to talk about the circuit breaker, or are we done here?
I mean, if you want to quickly get into circuit breaker, you could quickly mention it. We are this hour has gone by very quickly, but
right. Yeah, I just wanted to answer going back to the last plugin question about the memory usage of plugins, right? So we have the memory circuit breaker. I think we have docs we can send out on that, but that's a Appian guardrail that's preventing your expressions from using too much memory. But so it will pause the expression and check if it's using too much and prevent it from causing issues in your site, right? But one note there is that currently that's not functioning on plugins. So you have to think about, because like I said, we're passing the torch to the plugin code. The circuit breaker works by checking in the middle if the expression is growing too large, right? But because we're in arbitrary plugin code, we can't kind of stop it in the middle. It's a bigger challenge. So that is one of the risks of the expression plugins, is you are losing some of that freedom.
Good to know. All right. So yeah, this has been a really great hour. I mean, obviously, Daniel, you have a wealth of knowledge and could probably go on for a lot longer. So if people want Daniel to come back on and have more questions, please let us know in the comments or in the chat. But to me, it feels like the TLDR is really consider what do you actually need and only use that. And let's not, take for granted the fact that as we're building larger and larger applications, like every little extra bit that you're not using adds up.
Sure. Yeah. Great advice for Appian, for performance, for software, and for life as well. Yeah, exactly.
Yeah.
Yeah. All right. So I did say I have an announcement. So the announcement is applications are now open for the Appian World Live Build Challenge 2024. So this year, normally we have 6 people who are selected. This year we are selecting 12 participants who are going to compete in teams of 3. So if you have a team that you want to apply as, you can go ahead and apply together. Otherwise, you can apply individually, and then we can put individuals together on a team. The winning team will get a $30,000 cash prize to share. So that's pretty good. And you will also get a free hotel stay and conference pass to Appian World. If you're not interested in competing, but you still want to, get your face out there, we are also looking for presenters for our developer day. So if you do present for developer day, you will get a free conference pass to come to Appian World as well. And maybe a little bit less stressful to be, just amongst developers and presenting some type of fun technical topic. So you can find that information on community as well. Yeah, what else? Daniel, thank you so much for teaching Sam and I so many things. You've been a pleasure to have on. Hopefully you'll think about coming back. What do you think?
Sounds good. Yeah, let's see some more questions about any of those topics. Yep.
Yeah.
I'm learning too. Love learning. We're all learning.
Yeah.
Mhm.
That's great. We're all learning on the community YouTube channel. So please like and subscribe, and we'll see you in the next one next month to talk about all the fun things coming in 24.1. So thanks everyone. Bye-bye.
Thanks.